Welcome to the Computer Network series. Today we are going to discuss data transmission, which is one of the basic concepts in computer networks. Data transmission is basically about how information moves from one device to another. Whenever we start a message, download a file, watch a video, or make a phone call, data is being transmitted through a communication network. In this session, we will see different types and modes of data transmission. Let's first define what is data transmission. A data transmission is a transfer of data from a sender to a receiver through a communication medium. Typical examples include email delivery, video conferencing, file downloads, and mobile telecommunication. There are 5 important components in data transmission. Number 1 is a sender, the device that sends the information. Number 2 is a receiver, the device that receives it. Third is the message, the actual information being transmitted. Fourth is the medium, the path through which the data travels. And finally, we have the protocol, which is a set of rules that control communication between devices. Now, we are going to study data transmission from different perspectives: analog versus digital, serial versus parallel transmission, asynchronous and synchronous transmission, and finally, simplex, half duplex, and full duplex mode of communication. Each of these describes a different aspect of data transmission. Let's begin with the analog and the digital transmission. The analog transmission uses continuous signals. The signal can continuously change its value over time. AM radio, FM radio, analog TV are typical examples. The advantages include that it's relatively simple, the design is simple, and is suitable for continuous signals such as voice. On the downside, it's easily affected by noise and it is difficult to regenerate the original signal. That's too much difficult. Moving on to digital transmission, this uses discrete signals, generally repeated using binary 0 and 1. Typical examples include computer networks, Ethernet, USB, Wi-Fi. Major advantage is that digital communication has good noise immunity and supports error detection, making it highly reliable. On the downside, only thing is that we need encoding and decoding mechanisms to represent the information digitally. Fine. Comparing these two, analog is continuous whereas digital is discrete. Analog communication is more affected by noise. Digital communication provides better noise resistance and supports error detection. Traditional radio and analog TV are examples of analog systems, while Ethernet, USB, Wi-Fi, and computer networks are examples of digital communication. The digital infrastructure is the foundation of various technologies like fiber optic communication and high-speed switches. Digital systems also use error detection mechanisms such as parity checksums to identify corrupted data. Let's move on to serial transmission and parallel transmission. In serial transmission, bits are transmitted one after the other through a single communication line. For example, the bits 1, 0, 1, 0, 1 are transmitted sequentially. The main advantage is low wiring requirements, lowering cost, and good reliability over long distances. USB, Ethernet are some traditional examples of serial transmission. In parallel transmission, multiple bits are transmitted simultaneously using multiple communication lines, as shown in the picture. So, instead of sending one bit at a time, several bits can travel together. The advantage is that it's higher speed, particularly for shorter distances. However, on the downside, it requires more wires and can suffer from signal skewing, where different bits may arrive at slightly different times. Typical applications include old printer ports, internal computer buses. Comparing these two, serial transmission uses single line while parallel transmission uses multiple lines. Serial requires less wiring and is generally simpler and more economical, whereas parallel can provide very high speed over short distances, but it requires more wiring and has a greater complexity. So we choose between them depending upon the application and the distance. Distance is quite important. Let us talk about asynchronous transmission and synchronous transmission. In an asynchronous transmission, characters are transmitted independently. Each character is generally surrounded by start and stop bits. There is no continuously shared clock between the sender and the receiver. So this makes the system relatively much simpler, but the additional start and the stop bits as you look in the picture creates overhead and might reduce the effective data rate. So this type of communication is suitable for applications like keyboards and serial devices. Whereas synchronous transmission, the data is transmitted as a continuous stream or blocks, with the sender and the receiver synchronized with each other using timing information. Because we don't need start and stop bits here around every character, there is less overhead. Therefore, synchronous transmission provides higher throughput and it is widely used in high speed networking and optical communication. Comparing these two, the asynchronous transmission, characters are transmitted independently using start and stop bits. In synchronous transmission, data is transmitted as blocks or streams using coordinated timing. Therefore, asynchronous transmission is simpler and synchronous provides higher throughput. And the last is the simplex, half duplex, or full duplex transmission modes. The simplex communication means communication happens in only one direction. The sender can send data to the receiver, but the receiver does not send back data to that communication path. A typical example is TV broadcast. The TV station sends the program and the television receives it. Moving on to half duplex allows communication in both directions, but not at the same time. One device transmits first and the other device can transmit later. A very simple example is walkie-talkie. When one person is speaking, the other person waits and then they take their time. And the last one is full duplex. Full duplex allows communication in both directions simultaneously. Both devices can send and receive at the same time. A common example is a mobile phone. When I am speaking, the other person can also speak and I can hear them. Both directions at the same time. Done. So we have done with data transmissions. Any doubts, post it in the comment section. I'll be happy to explain. Thank you. Happy learning.